We have a proven track record of quality service. So don't wait. Contact us today. For all your school supplies such as office, field, janitorial and online shopping and shipping needs. At Joseph's Hub we make it easy for you in 4 easy steps. Step 1. Send us your request or list. Step 2. We provide a quote. Step 3. You place your order. Step 4. We deliver for free. At Joseph's Hub, we have a proven track record of quality service.
Mic test 1 2 1 2 3.
Contact us today. For all your school supplies such as office, field, janitorial,
Testing.
At Joseph's Hub, we make
1 2 3.
4 easy steps. Step 1.
Let me know if you're hearing me.
Your request or list. Step 2. We provide a quote. Step 3. You place your order. Step 4. At Joseph's Hub, track record of quality service. So don't wait. Contact us today. For all your school supplies such as office, field.
Alright, so tonight we'll be looking at the topic how to solve a pair of simultaneous equation using the matrix method or the matrices method. In this topic, it will reinforce a couple of concepts that we have done before, such as finding the inverse, right, of a matrix. And in order to find the inverse of a matrix, you have to know how to find the determinant, how to find the adjoint of a matrix. Right, so all those concepts will be in tonight. So tonight, this session here is going to be short on this particular topic, and I basically from there now, based on how how we feel, and so we can look at vectors, right? We're going to look at how to solve problems involving vectors. Maybe even try a past paper question, right? And maybe that'll be allow me to teach you the concepts a little, as crash course, so to speak. Right, so be relaxed. Remember, invite your friends, send the messages out, leave a message in the chat. Let me know if you're hearing me loud and clear. Right, these are the things to do to ensure that we have a smooth functioning tonight. Right, I hope to have a smooth session, and I hope that all the program and everything works as it ought to. Hope the internet do justice. And so that's where we are at the moment. So invite some friends. Let me see at least 4 or 5 new persons on the live. Right, and I'll start the session. Right, I'll start the session. So I'm here. I'm waiting on you guys. Right, if you hear me loud and clear, leave a message. Let me see, let me know.
For all your school supplies such as office,
share the chat, share the link also in the school groups and so on, right? Because all this helps, right? All this helps. It is about survival right now, right? One student requested that we look at solving quadratic expressions, right? Method factorization, and yeah, that's the last request I got from a student, but I don't know if there's any other area that wants to look at, right? But we need to communicate so we can work very smart, right? Very smart. So I'm just waiting and queuing up, right? Messaging for everything to work smooth and allow me to express myself in a way that they could understand. This is our prayer in Jesus' name. Amen. All right, so there were some drop frames just now while I was spraying, but I trust that that's the end of it. Right, that's the end of it. All right, tonight we have on screen a pair of simultaneous equations, and generally speaking, most of you will basically use the elimination or the substitution method to solve this. Tonight I'm going to show you how to use the matrix method. And for us to do this, there is a particular concept that we must all be aware of. Right? We must all be aware of. And this is the formula that I want you to keep as the guide for what we're about to do. I'm not going to show you how it's derived, in a classroom setting. I'll just basically show you how these formulas derive and stuff. Some part of me feel it's always good to understand the root of everything. All right, but tonight we're gonna basically just look basically at the, get straight to the concepts. So when you look at this equation, right, you must remember this formula. You'll have something like this. A, then we have times x is equal to b. As a good student, what would be your first question if I tell you this formula A times x is equal to b, or ax is equal to b? What would be the first thing you should be asking me? All right, you could leave a message down in the chat. What's the question you want to ask? All right, so you got to know this. What's the first question you want to ask? Ax is equal to b. I mean, just putting myself in your shoes, I would basically ask, or was A, was X, was B? So let's get on to it quickly. In this question, we have to understand that A are the numbers in front of the coefficients in each equation. So you have 4x, so 4 is A. So therefore, A is 4 minus 5. And you keep it just a square, just like how it is arranged. And you have 3 and you have 2. That is my A in this question. Make sense? Right? That's my A. So a good question will be, what is X? X is actually the two coefficients that you have here. You have X and you have Y. So you have X and we have Y. Not coefficients, the two symbols or terms. Sorry about that. And therefore, what is B? Well, B would be minus 6 and 7. Are we good here? So this is our X and this is our B. And sure you understand that concept. So anytime you see a pair of simultaneous equation, the coefficients of the terms is your A, and the symbols, the unknown, right? That is your X. And what it's equal to, that's your B. Are we all good here? So with that being said, let's take it up a notch. If you want to solve this, in other words, you want to find X. X behave yourself tonight. X is equal to A inverse times B. This is the formula that you would use to solve this problem. So if you can remember from previous class, we all know how to find the inverse of a matrix. So let's get down to solving this problem. So we already know what is A. We have to find A inverse. Now there's a long cut and there's a short cut. Which cut you want us to take tonight? So X is equal to A inverse times B. Therefore, we know X is X and Y is equal to, what is A inverse? So we have A over here. What is A inverse? Talk to me. What's A inverse? You should know that A inverse is 1 over the determinant of A times A adjoint times A adjoint I'm just writing it in a formula form for you. A adjoint and then that is how you find A inverse, and then therefore all this times B. All this times B. And B in our question is minus 6 and 7. Right? So that's basically, breaking down the formula for you. So if you need me to recap anything, just let me know before I proceed. Right? Drop a message in the chat. Tell me what is it that you didn't get. So let me go one more time. We have already determined what A is. A is the coefficients of each term. So we have 4, we have, take the sign, minus 5, we have 3, we have 2. X in the formula is the two unknown symbols, X and Y. And B is what each equation is equal to, minus 6 and 7. And if you want to find X, which is the unknown, X and Y, it is basically A inverse times B. And I'm explaining how do you find A inverse. It is 1 over the determinant of A times A adjoint. Then you have times B. So I think the only mystery here is how to find the determinant and how to find the adjoint. So if you remember from the last session, I could work this a little way off. Some students would try to pack all that work in on me there. All right, but I would desist from that. All right, just for the sake of simplicity. So in my margin or side, I'll find my determinant of A. All right, and then plug in everything. So the determinant of A is equal to 4 times 2 minus 5 times 3. Making sense here for you? Making sense here to you? Talk to me. So what did I do there? I basically took, if you look at A, notice there's 4 and 2 in the leading diagonal. So I multiply those two terms. And then I subtract the multiplication or the product of the other or the trailing diagonal. So minus 5 times 3. So this gives us what? It gives us 2 4s, 8, 3 5s, 15, since it's negative 5. It's negative 15. Negative and negative is a positive. So it's 8 plus 15, which gives us what? Right, so that is 23, right? 23. Are we good here? Any questions? Talk to me. Please, 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 please join the live. We encourage your friends to join the live. So it determines 23. So therefore, writing back this formula here, putting in what I have already. So it's X is equal to 1 over 23. All right, 1 over 23. All right, some person said their signal is dropping and stuff. I hope it's not. My video is dropping and maybe just your internet, but keep trying. Right, keep trying. As I said, I'm going to learn about this YouTube stuff with experience. All right, so we have 1 over 23, so we already find the determinant. The next thing I want to work in the margin is what is my adjoint. I don't need to do it there, but just for the sake of simplicity, just to show. So we know that A is equal to 4 minus 5, 3, 2. Now to find the adjoint, The steps are quite simple. Swap 2 and 4, the leading diagonal. So I'll swap it and I'll write in a new expression here. So let me just ensure that everything copacetic. So I'll go. So I swap 2 and 4. And I'll change the sign. I'll change the sign of the trailing diagonal. So I'll change the sign of -5 to positive and +3 to minus. So please note I don't swap those two. All I do is change the sign of the trailing diagonal. That's all I do. Change the sign of the trailing diagonal. So this gives us 5 and -3. All of this times -6 and 7. See if that makes sense to you. I should draw a line through here so you know that this is a separation, right? So remember, the inverse is 1 over the determinant of A times A adjoint. And for the adjoint, all you do is take A, swap the leading diagonal, 4 and 2, and change the sign of the trailing diagonal. So -5 becomes +5, and +3 becomes -3. And this -6 over 7, that is the value for B. Are we all good here? Any questions? Yes, anybody? Any questions? All right, drop your messages so I can know. If you need any guidance. I hope it's not me. All right, maybe that's why sometimes when I finish a video, I'm unable to see the ending of it. Or not something the ending or a part is missing. Right? Maybe when the feed breaks, it cuts it off. But I hope it's not me. I'm trying to use Bardic fastest internet. I don't want to promote it on the website right now. Right? So I'm trusting that it's relatively smooth. Anybody else getting problems with by the getting dropped? Good. So let's simplify this problem quickly. So here we notice that we have two scenarios. We could either multiply this 1 over 23 in this matrix and then multiply the answer from that by this matrix outside. Or we could multiply these two matrices first, then deal with the scalar quantity 1 over 23 on the outside. A good advice, I think, would be, based on my experience, is that you first simplify the matrix multiplication first, then you deal with the scalar. So let's go that route. So how do you do this matrix multiplication? Remember, the first thing you have to check to ensure that you could multiply is to see if the number of columns, 1 column, 2 columns, is equal to the number of rows. 1 row, 2 rows. Once the number of columns in the first matrix is equal to the number of rows in the second matrix, it means that you could multiply these two matrices. Right? I hope that's clear. So let's go through this here quickly. But to do this, we go row by column. So there's only 1 column here. All right, so let's go. So we go 2 times 6. So we have, I could leave this 1 out of 23 here. I'll put a big bracket and I'll go 2 times -6. I go 2 times -6 plus 5 times 7. So I went row 1 by column 1. Are we all good here? Then we go to the second row, minus 3 times minus 6. So we have minus 3 times minus 6 plus 4 times 7. Well, getting some serious warning by getting some serious warning. Are we all good there? Let's simplify and see what we get. It gives us equal to 1 over 23 on the outside. Let's simplify. 2 times minus 6 is minus 12. Then we go 5/7. Getting some drop on the stream. All right, so let's go. 5/7. Let's start 5. Then you have negative 3 times negative 6. That is what? Negative and a negative is a positive. That gives us positive 18 plus 4/7. Plus 4/7. 28. Simplifying, what do we get? Let's work this out. So we have x, y, to the 5 minus 12. So we have 23, 1 over 23 times 23. The next one, 18 plus 28. We have 46. So now we left with a scalar times a matrix, and this is quite easy. Remember, it says every term outside of the matrix must be, every term in the matrix must be multiplied by the term outside. So this gives us x and y is equal to 1 over 23 times 23. And the next one is 1 over 23 times 46. Simplifying, what do we get? What do we get? Talk to me. 23 into 23. So we have x is equal to 1 and 23 into 46. That is 2. And therefore we have y is equal to 2. And that's our solution. X is equal to 1 and y is equal to 2. And that's it. Matrix multiplication. Good. Quick review. We have a pair of simultaneous equation. It's in the form of A times x is equal to b, where A are the numbers in front each of the symbol with their signs. So pay attention to the signs. So A is 4, minus 5, 3, and 2. X is the two unknown symbols, x and y. And b is what each equation is equal to, minus 6 and 7. To solve a pair simultaneous equation, you must use the formula x, the unknown symbols, is equal to the A inverse of b. To find the inverse of any matrix is 1 over the determinant of the matrix times the adjoint of the matrix. To find the determinant, we use the concept whereby we multiply the leading diagonal. So in our case, this is A, so it's 4 times 2 minus 3 times minus 5. And when we simplify that, we end up with 23. That's the determinant of A. So in the formula here, 1 over determinant A, we put 1 over 23. A adjoint is whereby we take A as it is, we swap the 2 and the 4, and we just change the sign of the trailing diagonal. So negative 5 becomes positive 5, and positive 3 becomes negative 3. And that's what we have in our expression here. Are we good here? After which, we basically multiply these two matrices. We can multiply them because the number of columns in the first matrix is equal to the number of rows in the second matrix. So we go row by column. So we go 2 by minus 6 plus 5 times 7. Then we go minus 3 by minus 6 plus 4 times 7. Simplifying, we end up with 23 and 46 as the matrix. And therefore we multiply what's inside the bracket by what's outside. So 1 over 23 times 23 is 1. 1 over 23 times 46 is 2. So therefore, respectively, we have x is equal to 1 and y is equal to 2. And that's the solution of our matrix. I hope that makes sense for you. Any questions? Any questions? If there aren't any questions, all right, what I'm going to do, I'm going to pause this. I'm going to pause and end this live. And I'm going to come again and we're going to take a look at, let's give the replay a chance to run. I want to see if everything is safe because I'm learning about this platform too, right? And stuff. And maybe the internet is what's messing up things for me and for you, right? But I hope that's the concept tonight, was basically learning how to solve a pair simultaneous equation using the matrices method. Here we were able to reinforce the concepts of how to find the determinant, how to find the adjoint, and in other words, how to use both to find the inverse. Right? We also look on how you do matrix multiplication and scalar multiplication of a matrix. So all these concepts tied up in this one question. Right? So I hope this is helpful. All right? I trust that when exams come, there's something as easy as this for you to do.